It begins not with a roar, but with an ethereal whisper above the horizon. Somewhere beyond public reach, far from the prying eyes of satellites and foreign observers, a black delta-shaped figure cuts through the sky over a secluded, heavily secured test range in northeastern China. The moment is brief, almost surreal, the sky fractured by the motion of something new, something unfamiliar. At first glance, it looks like a distant echo of the J20 or perhaps a more evolved J31 variant, but this aircraft is neither. As it banks into a low G-turn, its wing shape, fuselage angles and engine configuration come into full view. What we are seeing in this rare high-definition footage is something altogether unprecedented. China's Shenyang JXDS, unofficially designated the J50, a stealth aircraft prototype that signals not just a technical milestone, but a philosophical shift in China's air power doctrine. Today, we're not just watching a jet in flight, we're dissecting it layer by layer, system by system, theory by theory. This is a deep forensic dive into what may well be the single most advanced combat aircraft China has ever flown, and perhaps the first tangible challenger to America's sixth-generation dominance in the sky. Let's begin with the airframe, because even in silhouette, the J50's visual language speaks volumes. Its Lambda wing platform, with its sharply angled leading edges and blended trailing surfaces, reveals an unmistakable intent, aerodynamic efficiency fused seamlessly with low observability. The shape itself is a departure from the more traditional delta configurations of the Chengdu J20 and the faceted, kite-like forms of Russia's Su-57. The J50's wings are not merely optimized for stealth, they appear to be shaped by supercomputing models to generate optimal lift distribution, shock-wave suppression, and turbulence control across multiple altitudes and flight regimes. The Lambda platform also promotes internal volume critical for housing fuel, sensors, and weapons, all while minimizing drag and radar signature. But what sets this design apart from any previous Chinese platform is the presence of articulating wingtips, control surfaces that shift mid-flight in response to rapid input changes. These wingtips aren't just elevators or ailerons, they are multi-directional aerodynamic processors. They adjust roll, pitch, and possibly yaw simultaneously. They may even function as adaptive radar reflectors, altering their alignment in flight to scatter incoming radar waves. If this system is even partially automated through the real-time onboard computation, it would represent a leap toward the kind of fly-by-optics adaptive flight control we expect in fully sixth-generation aircraft. Take a moment to appreciate what this means. In modern air combat, it's not just about speed and stealth, it's about responsiveness. An aircraft that can actively reshape parts of its aerodynamic profile in flight becomes exponentially harder to predict, track, and target. That's not just a technological advantage, it's a tactical revolution. Imagine a fighter jet that senses an enemy radar lock and instead of deploying chaff or flares, it simply adjusts its wingtips to reflect the signal harmlessly away. That's the battlefield potential embedded in what, to the untrained eye, looks like a simple moving flap. Moving rearward, we come to perhaps the most controversial and hotly debated feature of the J50, its engine configuration and exhaust nozzle design. The aircraft features a pair of two-dimensional vectoring nozzles, rectangular and flat, reminiscent of the F-22 Raptor, but arguably even more refined. These nozzles suggest multiple simultaneous design goals: high thrust efficiency, reduced infrared signature, and vectored thrust for enhanced agility. Flat nozzles help conceal the hottest parts of the engine, the turbine blades and combustion chamber, reducing thermal signature and therefore infrared visibility to enemy sensors and missiles. But they also channel exhaust in more aerodynamically advantageous ways, reducing drag while enabling precision vectoring during aggressive pitch maneuvers, tight loops, or super-maneuverable dodges. Observers have pointed out the serrated trailing edges, commonly known as chevrons, around the nozzle housing. These help break up the engine's heat plume into cooler, smaller streams that are harder to detect with infrared search and track systems. What's most important here is what lies inside those nozzles. While official sources remain silent, defense analysts speculate that the J50 may be powered by a next-generation evolution of the WS-19 or an early prototype of the WS-20B engines, long rumored to include variable bypass adaptive cycle technology. If confirmed, this would place the J50's propulsion system in the same technological league as the GE XA-100 and Pratt and Whitney XA-101 engines powering the US NGA program. Adaptive cycle engines automatically shift airflow between different engine stages depending on speed and altitude, allowing for optimal fuel efficiency, supercruise capability, and massive thrust output during combat maneuvers. This means the J50 could cruise at Mach 1.7 or higher without afterburner and possibly even reach hypersonic dash speeds in burst engagements. Mechanical improvements redefine how fighters manage heat, stealth, and performance in a single integrated propulsion. Zoom in on the Diverterless supersonic inlets. These are among the most refined seen on any Chinese aircraft to date. They are deeply embedded into the forward fuselage, angled with aggressive sharpness but shaped with subtle curvature, suggesting extensive computational fluid dynamics or CFD modeling. Unlike traditional variable inlets that use ramps and mechanical diverters to control supersonic airflow, DSIs rely on surface shaping and pressure gradients to manage shock waves. They are lighter, stealthier, and more reliable. The J50's inlets seem tuned for maximum airflow efficiency while maintaining tight radar cross-section or RCS suppression. That tells us the J50 isn't just designed for stealth at subsonic speeds, it's optimized for stealthy supersonic performance, a much harder technical challenge and a true hallmark of 6th-gen fighter design. Now let's dig into the landing gear, because here too the aircraft reveals more than it intends. The landing gear struts are thick, widely spaced and structurally reinforced, suggesting a high gross takeoff weight and potentially long, unprepared runway capability. The bay doors are cleanly recessed and likely sealed with radar-absorbent materials, with actuator arms neatly nested to avoid protrusions. This implies a large internal weapons bay situated centrally in the fuselage, critical for stealth missions and deep penetration strikes. Furthermore, the wide-set main gear points to a long wheelbase designed to stabilize the aircraft during high-weight landings, hinting that the J50 could carry a substantial internal payload, possibly in excess of 10,000 kilograms. That's more than enough for long-range air-to-air missiles, standoff precision weapons, or anti-ship hypersonic glide vehicles, all housed internally to preserve its stealth signature. Let's shift to sensor fusion, one of the defining elements of future air dominance. At various angles, we catch glimpses of conformal sensor apertures, infrared domes, and possible LAR ports. These suggest the presence of a fully integrated distributed aperture system, or DAS, likely combining electro-optical tracking missile approach, warning, infrared search and track, and real-time passive targeting. In legacy platforms, these capabilities were separated and often relied on discrete hardware. In the J50, these systems appear seamlessly integrated into the airframe, coordinated through a centralized mission computer that processes massive sensor inputs and infuses them into a single digital battlespace view. This is not about seeing the enemy, it's about understanding everything about them in real time. From range and vector to radar mode and data link usage. This is war by information dominance. The J50 is not just an aircraft, it's a doctrine wrapped in composite material. It represents a Chinese shift toward information-dominant, network-centric, stealth-first combat. It implies a future of coordinated satellite overwatch, swarming drones, and AI-managed aerial campaigns. The J50 is likely the spearhead of this new doctrine, an aircraft designed not just to win dogfights, but to dominate entire theaters through intelligence, speed, and silence. If you've stayed with us through this deep technical journey, if you're passionate about defense technology and want the latest updates on military advancements, this is a must-watch. Don't forget to like, share, and subscribe to our channel for more in-depth analysis.